So now we are going to talk about power series. So if we have a power series centered at the point x naught, the way we write this power series is the sum, sorry, I forgot I was sharing my screen. Here we go. The sum from n equals 0 to infinity of a sub n x minus x naught to the n. So the difference here is we are now throwing x values into our sums. So an is just going to be whatever thing we are utilizing to make the coefficients in front of our x's. And then we have x minus x naught to the n. So one of the reasons we start these at n equals 0 is so like your first term is your constant term, and then your second term is your linear term, and so on. So when we're talking about power series, one of the big things we're trying to determine is the interval and radius of convergence. These tell us for what values of x the series converges. So it's almost telling us like a domain we can define this power series on. And the way we find the interval and the radius of convergence is we use the ratio test, which is why we were talking about it today. So for example, let's say we have the power series, the sum from n equals 0 to infinity of n squared times x plus 2 to the n all over 3 to the n. And our goal here is to find both the radius and the interval of convergence. So our radius is going to be like how far from our center can we go on either side to determine for that convergence, where the interval is telling you like the exact x values it converges at. So we're going to start with the ratio test. So the ratio test tells us we're taking that limit as n approaches infinity of the absolute value of n plus 1 squared x plus 2 to the n plus 1 all over 3 to the n plus 1 times, and instead of writing my n term in the denominator, I'm just going to go ahead and flip it. So I've got times 3n over n squared x plus 2 to the n, absolute value of all of that. Okay. Everybody okay with that? All right. Pat, what does this simplify down into?
So we're gonna have x plus 2 greater. We're gonna have a 3 in the denominator, and then n plus 1 squared and then n squared.
Perfect. Now notice that this is a limit over n. So if this is a limit over n, we can pull our x term outside of the limit, right? Because the x is not affecting the limit at all, and we can pull constants outside of our limits So we can treat anything that doesn't have an n like constant. So I'm going to go ahead and pull out my x plus 2. The only thing I need to make sure to do is still have it in absolute value bars. The reason I am allowed to do this, let's make a little side note, is if you have the absolute value of a times b, that equals the absolute value of a times the absolute value of b. So I'm just utilizing that property and to be able to pull out my x plus 2 as an absolute value. And then I still have the limit as n approaches infinity of the absolute value of n plus 1 squared over 3n squared. So now looking at this limit, the degree in my numerator is 2 and the coefficient in front of that is 1 if you expanded it out. And then the denominator, my degree is 2 and the coefficient is 3. So I'm going to have the absolute value of 1/3 or just 1/3 as my limit. The ratio test tells me in order for this to converge, what do we need? 0 or less than 1, right? Less than 1. So we need this all to be less than 1. So if I have 1/3 absolute value of x plus 2 is less than 1, I can multiply both sides by 3 and get x plus 2 is less than 3. And then how can I keep solving this from here? Yeah, -3 less than x plus 2 less than 3. You could break it up into 2 separate inequalities if you wanted, or you can write it as one big string. And then if I subtract 2 from each section of my inequality, I'm going to get -5 is less than x is less than 1. So my interval is going to be -5 to 1. 80. Oh no. And then anybody got my radius? It's 3. Perfect. So if you ever get to a point where you have the absolute value is less than 3, as long as the coefficient in front of the x is a +1, like then you know your radius is 3, looking at that. But you do have to be a little bit careful because there are times when the coefficient in front of there is not a 1. But you can always just look at your interval, figure out what the center is, and figure out the distance. Now, technically, with a power series, you are supposed to then plug in your endpoints in for x and run the test again to figure out, like, do we actually want to include -5 and 1, or do we want to keep them both as parentheses? Because remember, at equal to 1, the ratio test is inconclusive. However, for this class, it's not necessary. So to save time, we're not going to worry about it. And you might have to use other tests that we haven't talked about in this class. So for me, that's good. Okay. Any questions about that? All right, one side note before we go to the board, it is possible for your inequality to always be less than 1, in which case your interval of convergence would be infinity, and -infinity to infinity. And it is possible for it never to be less than 1, which what do you think your radius is there? It's 0 and you don't have an interval. So those are possibilities as well. All right, let's go ahead and go to boards.